All right, everybody, this is 7.3 exponential functions. So we've talked about in our last lessons, we did quadratic and we did linear and absolute value. So we're going to review exponential functions. You should have done this before, so maybe this will be a nice review for you. If you don't remember it at all, then just pay attention really carefully, because we won't go too slow because you should already know how to do this. Okay, so what is different about exponential functions? So one thing that you would maybe notice is that we have our variable, that is our exponent. Okay, typically our variable in other equations is our base. And we've talked about bases and exponents. This is called your coefficient. Oops, coefficient. Okay. And when we talk specifically with exponential functions, a is our initial value, and b is our growth or decay factor. All right, so we may want to say, well, when are we going to have growth and when are we going to have decay? So let's look at some of these examples. So here we have a function, an exponential function, where b, our base, is 2. So let's see what happens. Let's fill in this table and graph and see what it looks like. So if we plugged in x equals -2, okay, you can do that on your calculator. You could even just graph this and use a table. That's probably what I would suggest. So if you have your graphing calculator, plug that in. This would be like your y equals 2 to the x, and then graph it. Or do second graph, gives you a table. So you'll end up getting something like 1/4, 1/2, 1, 2, 4, 8, 16. So it gets doubled every time. So we have 2, and then we have, this is like 2, and this is like 2 times 2, and this is like 2 times 2 times 2, and so forth. Okay, so we can graph this. We'll start with 0. 0 is 1, and then it doubles to 2, and then it doubles to 4, and then it's outside of my graph, okay? And on the other side, this would be a half, and then this would be a fourth. So an exponential function looks something like this, okay? And on this side, if we were to graph it, again, you could make a function or plug it into your graphing calculator and make a table. Here would end up getting something like 4, and then 2. So every time it's getting halved. Okay, so 4, then 2, then 1, then a half, then a fourth, and then an eighth, and then a 16th. So let's kind of graph that. So we have at -2, it's 4, and then 2, and then 1, then a half, fourth, eighth, and then it's getting so small that you probably can't see it very well. Okay, and it never will reach 0. So that's one thing that's kind of interesting about exponential functions. At least the form that we have it, it will never cross the x-axis. You can do other things like transformations that would make that happen. All right, so growth, we have growth whenever b is greater than 1. So here we did an example where it was 2. So as long as b is more than 1, every time it's going to be multiplied, it's going to get a little bigger. Decay is whenever b is less than 1. Okay? And really, I guess maybe we should put it smashed between 0 and 1. Okay? We won't do negative growth or decay. I mean, like, that wouldn't really make sense. So there we have our growth and decay. So determine the initial value and the growth or decay factor for these following equations. So pause and give that a try. So this would be our initial value, would be 60, and then here we would have growth because it's more than 1. So say growth factor is 1.41. Here we have our initial value, and this would be decay factor. I guess I'm okay if you just do that, if you do like an abbreviation. So this would be our initial value, and then this would be also a decay factor. All right, another way to think about growth or decay is to ask yourself what each value is being multiplied each time. So if you had a table and you wanted to try and find, assuming that this was exponential, we'd want to say, how could we find the growth or decay factor? So what we want to look and see, just like we did here, is every single time here it's being multiplied by 2. So here the growth factor here is 2. Here it's being multiplied by every time by a half, and that would be our growth or decay factor. So let's see what can be multiplied, what y value is being multiplied every time. So here it's getting bigger, so we know that it's going to be a growth factor. And then we want to say, well, what's going to be multiplied every time? So I'd probably start with something that would be easy. What do you multiply 1 by to give you 3? Well, 3. And then we'd want to see if it applies for the next one. 3 times 3 gives you 9. So here our growth factor is 3. Let's look at this one. Okay, so it's getting smaller as you go along. Y gets smaller, so this is going to be decay factor. And what is being multiplied every time? So another way you can kind of think about that is what is being divided every time. So if you were to say, what do we need to divide 8 by to give us 2? Well, it would be 4. So we'd have to divide by 4. Or another way you could do that is to multiply by a fourth. And we want to see if that applies for the next one. So if we multiply 2 by 1/4, that does give you 1/2. So our decay factor here would be 1/4. That one's a little trickier, going backwards like the decay, plus this fraction is kind of a little different. If it was like 1/2, I think you'd see it a lot easier. All right. Now let's talk about growth and decay rate. Okay, so the growth or decay rate is the percent change between each output value of the function. So let's see if we can figure out how we can come up with that. So we have these problems. I'm gonna write down what the growth rate or decay is, and you're going to see if you can come up with kind of like the pattern. So this is going to be growth. The growth rate for this one is 23%. So again, rates are percentages. Rates are percentages. Okay. Here's another one. This one is going to be also growth, a growth rate of 64%. All right, so what do you notice? Here's another one. This is going to be decay rate. Here will be 30%. And this will also be a decay rate of 60%. Okay. So hopefully you realize that at least for these ones, like the decimal is the same as your answer. Okay, it's just turned into a percentage. So 0.23 is the same as 23%. And 0.64 is the same as a decimal of 0.64 is the same as 64%. Okay, this one's maybe a little different, but what do you notice is perhaps that the difference between 0.7 and 1 is 0.3 or 30%. The difference between 0.4 and 1 gives you 0.6, and that's 60%. So the easiest way for me to think about that, if you're trying to find the growth rate or decay, just it's the difference from 1, and then we'll write it as a percentage. Okay. Same thing for the decay. We just look at the difference from 1. We don't look at, like, there's not going to be a sign. It's just always going to be positive. And then we'll write it as a percentage. There's like a formula or something like that that you can use. But I feel like it's easier just to think difference from 1, and then write it as a percentage. So let's do a couple examples of that. So here, initial value, whoop, we have 4. And you could do all those really quick, like -3. Growth or decay. So here I just want you to circle if it's growth or decay. Here it's decay because it's less than 1. Okay, its factor is going to be 0.78. And then its rate, again, it's the difference from 1. So you could do 1 minus 0.78, and that would give you 0.22. And then we need to write it as a percentage, so 22%. Okay? Or maybe I should put that step in here. So we do something like 1 minus 0.78, and that equals 0.22, and then we'll just write it as a percentage. Okay? Give B a try. So this is going to be growth because it's more than 1. Its factor is 1.47. And then its rate will be 47%. So again, you're going to do the difference from 1. Oops. Give us 0.47, and then we'll write it as a percentage. Okay, initial value here is 0.6. It is growth. Its factor is 1.19. And then its rate, again, is the difference from 1. So we'll do 1.19 minus 1 equals 0.19, or 19%. All right. Okay, what do you notice between the equations that we do above, that we just did, and the ones below? Have a look at those and see if you notice something different. I'm hoping you realize that we have like a coefficient in our exponent. So here we have a 2, here we have a 3, here we have a 3. Okay, so to be able to find your growth factor or rate, it has to be written in the form that we have at the beginning, where we had y equals a times b to the x. All right, so the way it is now, our growth factor here, we do have growth, but the growth factor isn't 1.25. Okay, we need to evaluate that. We need to evaluate 1.25 squared. Okay, so just like we did with our exponent rules, and when we did exponent rules, oftentimes we had something like this. And then our rule was, is if we have a power to a power, we were able to multiply them. So here we're basically doing the opposite. We're going backwards. We have 2 times x. So it's okay to be able to just put a parenthesis around those and make it like a power to a power. So we're just going to put parentheses and leave the variable outside, and we're just going to evaluate what's inside. So here our initial value would be a 1 in the front. We have growth, but we need to evaluate, so you'd want to grab your calculator and do 1.25 squared. And then I would just want a decimal, and don't round. So here we have 1.5625. So that would be our, oops, that should go here. That's our growth factor. And then its rate, again, is the difference from 1. So that would give you like 56.25%. So, and we write our decimal as a fraction. And maybe I should focus on that a little bit more. So if you want to write a percentage, we just move the decimal over twice and put a parenthesis after that. Not a parenthesis, a percentage. All right, let's try this one. Pause and give it a try if you'd like. So this one is going to be initial value again is 1. If we don't see it, it's going to just be a 1. We're going to have decay because it's less than 1. And then we need to evaluate. So 0.68 to the third. And that gives us a big decimal. I'm just going to actually round to the tenths or hundredths place. So we'll 0.31. And then our decay rate, again, it's the difference from 1. So 1 minus 0.31. 1 minus 0.31 gives us 0.69 or 69%. Okay, give this one a try too, if you would, pause. So we end up our initial value of 2. Again, we will just put a parenthesis around that. We'll do 1.1 to the third. And that gives us 1.331. Sorry, that should go here, and this is growth. And then the rate here will be 33%. So the difference from 1 will give us 0.33, and we'll write it as a percentage. All right. The last thing we're going to cover is just a couple of word problems. We'll need to write our equation. That's the first step. That's one I think I really want to make sure you get that, and then we'll evaluate it. So Ben deposits $100 into a savings account. So that is going to be like our initial value. And it has an annual growth rate. So this is like your percentage. That's like this kind of stuff. Is 4%. How much will he have after 12 years? All right, so again, our equation here is y over here. Y is equal to a times b to the x, where b is your growth factor. So if they give us a rate, a percentage, we need to write it as a factor. So again, we'll do basically the opposite. We'll take that decimal, move it twice, and then instead of subtracting 1 or something like that, we'll add 1. So to have it be growth, it's got to be 1.04 to have it be growth. All right, so we end up having our equation that's y equals 100 times our growth factor.
Aubrey Davis,
Sorry.
you are needed in the aux gym.
And then we have.
Aubrey Davis, please come to the auxiliary gym.
And then we have our x. Okay. If we want to evaluate that, we would just do 100 times 1.04 to the 12, because that's how many years we want to do it for. So we'll do 100 times 1.04 to the 12th, and you should end up getting something like $160. Okay. All right, so that is kind of tricky, is like coming up with your factor from a rate. So again, let's just talk about that really quick. So our rate here was 4%. If we want to write it not as a fraction, or not percentages, but as a decimal, we do the opposite. We take that decimal and move it to the left twice. Okay, and then since it is growth, it's going to need to be 1.04. And if you can always check and go backwards, and you could like say, well, to go back to the percentage, you could do the same thing. So you could say, well, I'm going to take it's a difference from 1, so I'm going to do 1.04 minus 1 gives you 0.04, and then I'll move my decimal over twice to give me 4%. So you can always go back and make sure you got it right. All right. A new car costs $24,000. it loses 18% of its value every year after it's purchased. This is called depreciation. Determine the value of the car, not the care, the car after 4 years. Okay, so again, this is going to be initial value. This would be our decay, because it's going down, it decreases every year. So the decay factor, or rate, sorry, that's a decay rate. And we'll need to write it as decay factor. So to do that, so we have our 18%. It loses 18%. And really what we need to look at is what we have left. So if we lose 18%, how much do we still have? Well, we lose this, but we keep, how much would be 1 minus, or like 100 minus 18. That would leave us with 88. So we lose 18% every year, but we keep 88, or sorry, I'm getting that totally off. It should be 82. 82% every time. So we write that as a decimal, that would give us 0.82. So that would be our decay factor. So we'll write our equation, y is equal to 24000, and then our decay factor would be 0.82, and we want to know how many years it is, so that would be our equation, and we'll just evaluate it when x equals 4. So y is equal to the same thing to the power of 4 for 4 years. And we will, I left the 0, and we would plug that into our calculator. So 2400 times 0.82 to the 4th. So after 4 years, it's only worth just a little less than $11,000. So you lose quite a bit of money over time. So it's not a very good, a good thing to like invest in. Okay. Last one. Every year, a local. I think I'll probably skip this one. I think those two are probably the best that will help on your homework and things like that. So if you have any questions, please let me know, and we'll see you later.